Alright guys, this is the video for the first part of section 7.5. Now section 7.5 is the last section of chapter 7. So that means your test will be coming up soon. So this is all about trapezoids and kites. So in this video we're going to talk about trapezoids. There'll be another video for kites. But first we want to define what a trapezoid is. Okay, so the definition of a trapezoid is it is a quadrilateral, so quadrilateral meaning it has 4 sides. A quadrilateral is a trapezoid if and only if it has only one pair of opposite parallel sides. Okay, so the shape that this definition is in is a trapezoid. I know most of you know what a trapezoid is. So basically, per this definition, these 2 sides are parallel, the other 2 sides are not. So it has only one pair of opposite parallel sides. So something to note, this is not a parallelogram. All right, so the trapezoid midsegment theorem tells us that the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the base, 1/2 the sum of the lengths of the bases. So that is confusing to a lot of people. So I always write that the length of the midsegment is the average of the 2 bases. And that seems to be a lot easier for people to follow. All right, now once we've done this and this, go ahead and cut that trapezoid out and paste it in, but paste it in either on the top or the bottom, because we're going to talk about the anatomy of a trapezoid, and this is something you're just going to write in your notebook. All right, so I went ahead and I drew a trapezoid, and you can too. Please do. Like I said, give yourself some room, and I'm going to make sure we know these are parallel. Okay. So this is a base, and this is a base. So I'm going to put over here the bases, are the 2 parallel sides. Okay, so the 2 parallel sides are called the bases. The other 2 sides that are not parallel are called the legs. So I'm going to say the legs are the 2 non-parallel sides. All right, so we have a midsegment theorem. So if I find the midpoint of AB, it'll be here. And if I find the midpoint, go ahead and erase this, the midpoint of CD, it'd be here, okay? If I connect those midpoints, this is my mid-segment. Okay, so the mid-segment it connects the midpoints of the 2 legs. Okay, so you have one mid-segment and it's halfway between the 2 bases. All right, the next concept is kind of tricky to understand. So we have one base down here. So both of these bases, or both of these angles along the same base, this would be a pair of base angles. Okay, and then the same thing up here. those shouldn't be the same. So here and here, these are a pair of base angles. Okay, so I'm going to put a note over here that base angles come in pairs. They are the angles along the same base. Okay, now one other thing I want to point out, because these two bases are parallel, that means these two are supplementary. Oops, can't spell. Because they're consecutive interiors, and also these two are supplementary. Because they are consecutive interior angles. Okay, and that should be it on the anatomy of a trapezoid. All right, now I'm just going to add this on this foldable, or this cutout of an isosceles trapezoid, the definition. So I'm just going to write it in there. And the definition of an isosceles trapezoid is a trapezoid in which the legs are congruent. Okay, so we have a trapezoid here, right? This and this are the bases, they're parallel. And an isosceles trapezoid, the legs are congruent. So these two sides are congruent. And as we will see, there's a lot of properties that come with isosceles trapezoids. All right, so we have the isosceles trapezoid base angles theorem. And this theorem tells us that if a trapezoid is isosceles, then its angles along the same base are congruent. Okay, so if I have an isosceles trapezoid like that, this angle and this angle are congruent, and then this angle and this angle are congruent. Now the converse of that, remember a converse is when you flip the hypothesis and the conclusion. So the converse says if a trapezoid has congruent angles along the same base, then it's an isosceles trapezoid. All right, an isosceles trapezoid diagonals theorem tells us that a trapezoid is isosceles if and only if its diagonals are congruent. All right, let's look at example 1 now. If we go back to when I did the anatomy of a trapezoid, remember I said that angles along the same leg are supplementary because they are consecutive interior angles, okay? So these are consecutive interior angles, and because these are parallel, I know they are supplementary. So if they're supplementary, that means they add to 180. So I could say 12x plus 3 plus 13x plus 2 equals 180. So 12x plus 13x is 25x plus 3 plus 2 is 5 equals 180. Minus 5 minus 5. I get 25x equals 175. Divide by 25. I get x then has to be 7. All right, let's look at example 2 now. Okay, so EF here, this is the mid segment. Okay, so it's halfway between DC and AB. Okay, so it says if AB is 7y plus 6, EF is 5y minus 3, and DC is y minus 2. Find the value of y. All right, so we said the mid-segment is the average. So I'm going to write this out. Mid-segment is the average of the two bases, so of DC and AB. So I could say that DC plus AB divided by 2, that's going to equal the mid-segment, which is EF. Okay, well now guys, I can just plug stuff in and do some algebra. So EF is 5y minus 3. That's going to equal DC plus AB, so DC is y minus 2, plus AB is 7y plus 6 divided by 2. Okay, anytime we have a fraction, we're going to get rid of the denominator. So multiply this by 2. Remember, you have to put this in parentheses, so those would go away. We'd distribute this through, so it'd be 10y minus 6 equals, well guys, y plus 7y, 8y, minus 2 plus 6 is plus 4. Okay, now let's do some more algebra. So minus 8y minus 8y, I get 2y minus 6 equals 4. Add 6, 2y equals 10, which means that y has to equal 5. All right, let's look at example 3 now. It says done, D-O-N-E, this trapezoid, is an isosceles trapezoid. Okay, and the measure of EDO, so EDO is this angle here, it's 110 degrees. And DEN, so this angle down here, is 15x minus 5 degrees. All right, so if you recall back to example 1 and our anatomy of a triangle or of a trapezoid, what relationship do these two angles have? Well, these two angles are supplementary, and therefore they add to 180. So I could say 110 plus 15x minus 5 equals 180. And now it's just algebra, so 105 plus 15x equals 180. Subtract 105. 15x equals 175. Divide by 15 on both sides. I get x is, sorry, that's not 175, it's just 75. X is 5. All right, here's the last example for the trapezoids. Not for the whole section, but for the trapezoid. So it says trap is an isosceles trapezoid. This is important here. PR is 3x plus 7 and TA is 20. Okay, so PR is a diagonal and TA is the diagonal. So if we go back to look at the trapezoid diagonals theorem, we see that the diagonals are congruent, right? That's what this theorem says. A trapezoid is isosceles if and only if diagonals are congruent. So if they are congruent, that means these two are equal in measure. So 3x minus 7 equals 20. Add 7 to both sides, I get 3x equals 27. And then x equals 9.